Okay, well, I will go ahead and start, and I'll say good morning to Victoria, but I'm waiting for my phone to actually, remember how to work, um, so that I can have Slack open, but that's apparently a little too much for it right now. Poor little thing. All my other workspaces work fine, except for... Nope, it's all of Slack, never mind. Let's do that. Now let's see if it works. Oh, that looks a lot better. Oh, yay, there we go. It actually works now. Yay, they hear me. Excellent. Okay. Cool. So, yesterday you got to play with SQL. How do you like SQL? I, not your favorite thing in the world. uh, yeah, dreaming about SQL is not uncommon. Usually we call those nightmares, but yeah. Uh, so I'll say something that might even sound slightly controversial, but I promise it's true. As a web developer, you only ever need to be adequate at SQL. Yay! Um, I mean, there are still plenty of people out there in the world that have delusions of adequacy and a failure to achieve. But the truth is, with SQL, so much of what we do on a day-to-day basis with SQL is focused on our very specific CRUD tasks. So 95 to 98% of everything you're ever going to do with SQL is your basic select statements, inserts, updates, a join query here or there. That's most of it. Every once in a while, you'll have to write some gross complex query, but that's going to be like once or twice a year. That the queries are going to get really, really grotesque. So SQL is the flip side to that, though, is while you never need to be some extreme expert at SQL unless you decide to become a database administrator, the other side to that is that adequacy of skills has to be at the tip of your fingers. Like, you absolutely have to be able to call on that on a moment's notice, because just about every job interview is probably going to have a SQL question in it, and they're not going to be asking about what libraries you use to talk to the database. They're going to ask you about writing SQL queries. So it's a skill that you're going to have to keep. And the other side to that is, not only do you need to keep your SQL skills up just for job interviews, but on a day-to-day level, there's going to be cases where you're going to want to test your data outside of your code, and you just need to be able to drop into the command line of your database, write a SQL query, and understand A, what you're doing, and B, what you're getting back. So while you don't ever have to worry too much about mastering the complexities and the intensities that can get into SQL, the core thing is to know that those skills just need to be there at a basic level. So with that being said, yesterday most of what you did was focused on just raw SQL. Well, today we want to have that Reese's peanut butter moment where we mix SQL and JavaScript together so that we get something that's greater than the sum of its parts. And basically this translates to, how do we get our JavaScript application to start talking to SQL? So in order to make that leap, we have to start understanding what this connection is going to give us. And what it's going to give us is something particularly cool, which is now we get to correspond a row of data in a database, so one record in a database, with a code object. And so if we have a table that has 10 rows in it, we can get a list of 10 objects out of that. and be able to work with each one of those objects programmatically. Theoretically, what should happen is if I have, let's say, a users table, and that users table has an ID and a username and an email and a password and an admin flag on it, I should be able to get back an object with the keys, ID, username, email, password, admin, and the corresponding values set on those keys. I should be able to have that one-to-one correlation between a record in the database and an object that I can then work with. And the other thing is I should be able to go back and forth between them. I should be able to make a change to that object and then save it in the database. That would make sense. So this is where libraries come in that do this connection between SQL and our code. Every language has got them because SQL has been around for quite a while. And we're going to start off this morning with one where we're going to be talking directly to the database because there's a couple things we need to learn with that before we move on to some of the other libraries. And in particular, security. Security first is something I want to start encouraging with all of you because SQL is the one place where the web developers most consistently make the biggest mistakes when it comes to security. But let's start off. I have already created a package.json, and I have taken the liberty of installing the PG module, mostly because watching npm modules install is incredibly riveting, I know. But I went ahead and did that this morning. And now it means that we are able to do a few cool things. So what I'm going to do is I'm going to create a file. I'm just going to call it index.js. And I'm going to start bringing code in that's going to allow me to do what I want to do. For starters, I need to bring in PG. So now I have that. In order for me to take the PG module for Postgres and connect it to my Postgres database, I have to know how to make that connection. And as a standard with Postgres and MySQL and a bunch of other databases, there are 4 things you always need to know. So I'm going to stick those in a config object. And those 4 things are, what's the username? In this case, I'm Don. What's the password? I don't have one on this database. What is the database named? Well, I've got one with a whole bunch of hockey data in it that we can play with, so I'll use that one. It's called hockey. And what host is it on? And in this case, it's localhost because it's running on my machine. These 4 things you will need to know for connecting to pretty much every database except SQLite. SQLite's different in that you only have to point it to a file. Morning, Nick. It's 9:12. Just thought I'd let you know. Guy's going to be late to his own wedding. Or funeral. So, sorry, Victoria. I have to give them grief when they show up late. So yeah, these 4 things, your credentials, your username, password, what database you're connecting to, because I have many databases running in my Postgres server, and what host it is. So that might be here on my local machine, it might be somewhere else on the internet. You'll also see in the documentation, mostly because I'll point to it and go see, it's here in the documentation, that you can use something called a connection string, which is a URI. That is going to indicate the protocol and the username and the password and the host and the database all as one connection string. And if that's comfortable for you to type, awesome, do it. It works. And it will be read. If not, you can put the values in manually. And so now that I have my configuration, I need a client. Because my Postgres, that's my server, in this case, that I'm talking to, the server being the piece of software that is listening for an incoming request. Yeah, Gabe, actually all of you could be late and I would never know. Um, but you guys are vocal enough that if you're not talking at the beginning of lecture, I know something's wrong. Uh, so my Postgres is my server, meaning that's what I'm going to be sending requests to. So I'm writing a client at this point. So I need to create a client. And my PG gives me, if I could spell, a method called client to create this. And I'm just going to pass it my config object. And so this gives me a client that I can now work with. Unfortunately, there's one more thing that I need to do before I can actually start making queries. And that is that. If I don't connect, I got nothing. So now that I'm connected, now I can actually start doing things. So let's make a query. So I'm going to use the query method on my client object. And let's just count how many players there are in the players table. It's a SQL query, so it ends with a semicolon. And then it's going to get a callback, because this is an asynchronous operation. I'm going to make this request to my server, but I have no guarantee when the results are going to come back. When that state of data changes, I need an action to be registered to take place. That's the function of a callback. Standard node pattern of having the error first. And then the second is going to be the results. So let's set up some error handling. And we'll log out our results. So whatever we get back, we're going to log it out and see what it is. Everybody with me so far? Cool. So that's what I get back. There's a bunch of stuff there. Some of it's even relevant. So there, in my result object here, I have a key that is what command I ran. So it's the SQL command. In this case, it was a select. How many rows I got back, a row count key. OID, I have no idea. It's null anyway. Then there's a rows with an array that has an object in it of count 888. That looks like what I requested, because I requested it to come back as count. Then there's some fields. Tells me that the name is count, the table ID is 0, column ID is 0, data type ID is 20, data type size is 8, data type modifier is -1, format is text. Not terribly useful for me. There's some parsers in there. There's a rows CTOR, don't know what that is. Rows as array, false, and more functions. There's a lot of stuff there. That is the entire result object that comes back from Postgres. What I need to care about is this right here, the rows. That's going to be the key always that contains your results. And what we can do is we can actually write a little bit more interesting query and be able to see that a little bit better. So let's select star from players, limit 5. Now when we run it, there's a whole bunch of stuff there in parsers, don't care. Whole bunch of fields, don't care. This is what I care about. Under rows, now I've got Sidney Crosby, I've got Patrick Kane, I've got Nicholas Backstrom, I've got Nikita Kucherov. Like I'm actually getting players. That's where my player data is. So now, just as a general rule, I know that when I am working with the PG library, instead of just logging out res from now on, I'm going to go straight for res.rows. That's where the relevant data is. All the other stuff is what we would call metadata. It helps me if I need to go in and find out information about the action that PG took of making that query. But for the point of getting my results back, what I care about is the rows. So this now makes my data a lot more interesting to look at because I have separated signal from noise. That's important. So now I have an array of JavaScript objects that I can work with. So that means I can now forget about the fact that this came from SQL. Because now anything that I want to do with this data is just a JavaScript issue. Because at this point, there's nothing here that has anything to do with SQL. Once I have written out this query, run it, and the data has gotten into my callback, I can do whatever I want to with it. So let's do something with it. So if there's no error, I'm actually going to rewrite this so that I get rid of this else condition. So I've got res.rows. That's got players in it. Let's loop through those players. So res.rows for each player. And let's say name, player.name, and we'll log out their position. Sounds good. Now it's just data. I knew how to write the SQL query because I knew what I wanted to get out of my table. That was step one. Now I run my query, and in my callback where I actually get my data, I only have to worry about JavaScript problems at that point. My SQL problems are done, which is kind of a cool place to be. Now, whatever I want to do to format this is all about my output. The only thing I have to curate about this going forward is either A, how I handle the error, or B, what I decide to do with the data. Because if I change this query, let's say I change it to this, this is now going to fail because I'm not getting players back, I'm getting teams back. Okay, so let's take a look at what we're getting back here. Console.log, res.rows. I will look at my first 5 teams. Well, that looks pretty easy. I've got city and name. Okay, so if I wanted to be able to show that properly, res.rows.forEach, team, console.log, team.city, team.name. There we go. That's a JavaScript problem, not a SQL problem. So that means that the hard part is just learning the syntax of whatever you're using to connect to your database. That's the hard part. And I'd like to make it hard, but I can't. Because by now you already know how to read documentation. And you know how to look at example code and go, oh hey, how does that work? So if we actually check out the documentation for the node Postgres, which is at node-postgres.com, so for the actual PG module, we see that it's pretty easy to require PGN. In this case, they have just destructured out the client. So instead of doing pg.client, they've just pulled it out that way. They've made a new client, they've connected, and they've made a query. They've used a slightly different syntax here, which we're going to get to in just a moment. But when they log things out, it's res.rows 0, so they grab the first result, dot message, because they selected something as a message. And they would get hello world. And then they closed their database connection and they were done. Good for them. So that looks pretty cool. Here's my information about connecting. I can connect using pools. Here's setting the host and the user and the database and the password and maybe the port. Here's how I would pass that as one big object. If we look at queries, well, there's almost the exact syntax that I used. Client.query, a string that is the query, and then a callback function that takes error and res. So this is one of those situations where I'd love to make this difficult. I'd love to tell you that I'm revealing some great mystery to you at this point. No, not really. This becomes a pattern that you will find quite frequently in a lot of JavaScript stuff, especially when you're doing back-end node development, is as long as you understand the basic mechanics, then most likely what's going to happen is you're going to run a function, pass your argument, and have a callback function with error first as your parameter. And that's a pattern that you get to follow over and over and over again from now until the end of time. But let's actually look at some cool things that we can do with queries. So if we've got clients and players and teams, that means we probably have a team ID on the players. I promise we do. So if I wanted to, for example, get a list of players who, let's say, play on the Canucks. Sure, why not? This is an old database, so it doesn't have current people. I would probably need to do 2 queries. Why would I need to do 2 queries? I don't necessarily have to, but why would I jump to doing 2 queries for this? The desired output is to have a list of players who play on the Canucks. Well, so yeah, I'm going to have to join, yes. But let's say my thought experiment's failing. Yes, we do need to do a join, and we can do it all together as one query. The reason I was saying 2 queries is because what a lot of people will reflexively do is they'll do 1 query to find out who the Canucks are, like where, what ID it is in the database, and then they'll do another query to then create the join. But we can do it all together as one. Let's say that I want players.name, players.position from players, and then I want to left join teams on players.teamid equals teams.id, where teams.name equals Canucks. Sounds about right. Except for one small syntactical. Oh no, that's actually not going to be a problem because I wrote the quotes the correct way. Pro tip: use double quotes for your strings when you're writing your queries, because if you pass double quotes to Postgres, it thinks that you're referencing a field name. So that means strings like Canucks in there would need to be in single quotes all the time. So just as a habit, try and get in the habit of wrapping your whole query in double quotes. So it will save you that problem. So Once again, let's look at what res.rows gives us. I should go ahead and be good and add a client.in to that. Oops. Well, wait, why did that happen? I actually, that was something I was going to get to later, but why did I get a message that the client terminated instead of getting my results?
You got an error?
Well, I did get an error. Here's the error I got. Error, connection terminated.
Yeah, and then after it says client closed. The function, the query finished, you got your error, and then the next thing ran, which was closed.
Okay, so yes. Yeah, wrong one. Talk me through that one more time.
Well, you connect, client
Yes.
connect, and then you run your query.
Yep.
You got an error, so you don't print your results.
Right, but I shouldn't have gotten an error at that point. Hmm? Correct. Tony wins a cookie. What's actually, this is an asynchronous operation. So what's actually happening is it's running client.end before the query actually runs or gets back, and so the error that I'm getting is that my connection was terminated. So the trick to solving that problem is just to put that inside my callback, so after everything's done, then my client ends nicely and gracefully. So now when I run it, oh look, I get back what I would expect to get back. I'm getting back an array of objects that have the fields that I requested. The nice part is I don't have any kind of weird naming scheme. Even though in my query I said I wanted players.name and players.position, that's naming it coming out of the table. My objects are still just name and position. So it's easy to work with at this point. So that's, even if I'm doing a join query and limiting the results of the data that I'm getting, not a problem. Because it's still just going to give me a nice, tidy way to interact with this data in the way that I would expect to do it. But that's how I would, for example, run a join query. But let's now take this one step further, where I want to be able to run my script, pass a word in on the command line that is the name of a team, and then have it look up the list of players that play on that team based on what I type in. That's starting to make this a little bit more interactive. So I'm going to processed argv slice 2, and that's going to give me the team there that gets typed in. And in doing that, I can now come down here and I can, let's do this version. I can do that. That should work, right? Yes? I've got some general sures. Let's test it out. Yep, that worked. And that seems like the right first reflex to do to solve this problem. Except I'm taking a huge leap of faith in doing that. I'm trusting that my users are only ever going to give me great data. What happens if that is what gets typed in? It's going to delete the players table. This is what we call SQL injection. So if I take what is passed in on the command line and I pass it in directly to my query and just concatenate it in or interpolate it in, I am leaving myself wide open for this to happen. And this would be a terrible thing, especially if this was my production database and this was my login form and they did drop table users, which has happened more than once. So we don't do that. And this is that security first. Yeah, Shmoo.
When it's being passed this way,
Yep.
I'm assuming Canucks are still getting passed into name and select query line.
It is still getting passed, so Canucks is still getting passed in.
And then drop tables, because there's a semicolon, so then drop tables is occurring after that query. So presumably you'd get the printout and then everything would be erased and then it would close.
That is 100% correct. We would get the printout, and then everything would disappear and it would close. Yeah. And the worst part is I wouldn't necessarily be any the wiser until I went to run the next query. And then I would be in for a big surprise. Yeah. And the way this works, and just for those of you who are syntax nerds, the single quote and the semicolon ends off the query that was running before. The drop table players is a new query, ends with a semicolon, and then this dash dash here, anything in SQL, anything that is preceded by dash dash is considered a comment. So it just comments anything else that may be coming out after the query. So it forces the first query to run, ending it at the Canucks, and then drops the table and as a second query. Because SQL doesn't care how many queries you pass to it in a single string. As long as they're separated by semicolons, it will continue to run them. Yeah.
Why is there a single quote after Canucks?
The reason there's a single quote after Canucks is because it's being passed in as a string. So therefore, I know in Postgres that it's going to be wrapped in single quotes. Because if it was double quotes, this would be the name of a field.
So then why isn't there one in front of it too?
Because the reason there's not one in front of it is because I know that that's already been added into the query. And so I want to close off the string that has been opened up to put my text in there.
Okay. And so that you can configure it either way depending on how you write the query.
Right.
You'll get an error because it will be like the next drop table players. If it was kind of part of that.
Oh, because it means the whole thing might be a string.
Right. Yeah. So at that point, well, I would if I tried to put a string on the front of that, then it would be really confused, and I would actually get a syntax error because the two quotes would have been closed off, and then there's the extra text after that, which now syntactically doesn't make sense. So I would get an error out of it at that point. But then as if I was somebody trying to do something malicious, that would tell me something about how the query was written, and I would then be able to move forward in writing a better injection to affect my database. So this is bad. We're not going to do this. Instead, we're going to learn about something called parameterized queries. So I can use this substitution, the $1 here, and then I can add a parameter to my query method. And I put my team in there. And $1 in this case, contrary to intuition, is going to refer to the first thing in the array, which is index 0. So, yay. You still get to 0, 1, 2, 3, 4, but can you prove it works? No, Josh, I'm not going to drop my players table. Nice try. But what this does at this point is this saves me the grief. Yeah.
What do you call that kind of string?
Parameterized query.
Parameterized query.
Yes. So it's a term you want to love and become near and dear to your heart because it is the guaranteed solution across all database libraries and all languages to prevent SQL injection. Little note on SQL injection. there's something called the OWASP Top 10, which OWASP is the Open Web Application Security Project. It is an open source, community-driven initiative that has been around for about 20 years that documents the top vulnerabilities in security on web applications. And every couple years they put out their top 10 list, and the number one thing on the top 10 list for the past 20 years has been SQL injection. And it's because people lazily take user input and stick it right into a SQL query, and it makes them vulnerable. And if you don't believe me, ask Ashley Madison, or Target, or Sony PlayStation Network, or the FBI website at one point. Yeah, that one was embarrassing. They had added a newsletter sign-up box or a mailing list sign-up box on one side, and that one ended up being vulnerable. All the rest of the site was pretty much locked down. This one box on the one side was vulnerable and got hacked. And it's sad, but that's what happened. And so now when we run this, we get back nothing. Well, that's weird. Why did that happen? Actually, that's a really good question. Why did that happen? Oh, no, I did. Probably need to put quotes around it. Yep. Nope. Bind message supplies 1 parameters, but prepared statement requires 0. You lie. This is not my first rodeo. Why would this not work? Let me stare at this for just one brief moment. Why would I get back 0 results?
So then you have to put square brackets after it? Because the 6 of it was the where dot name, team dot name equals $1. But then there's a huge chunk of it. Okay, I was thinking of that. Maybe.
Huh. Huh. So here's proof. Here's the documentation. See, it's doing $1, $2 here, and then it has the values right there. And it passes the query, it passes the values, it passes the callback function. So why would that fail? That's kind of awesome. Not awesome at all, actually. Well, that's just the parentheses here are the syntax for the values clause for the insert. That's not specific to parameterized queries. That's just the SQL syntax that's needed for when you're passing values to an insert. Sorry, I can't hear you actually. Yeah, I am using a semicolon, but that shouldn't be the issue. I mean, we can take it out. And I still don't get any rows back. So yeah.
Because you're using slice. Slice returns an array, doesn't it? So you're going to have an array with, wait, I can write it.
Could be. Works now. Because it worked before, that was the thing. Yeah, you're right, slice does return an array. So yeah, that's what was doing it. So thank you for catching that. because, yeah, what happened before is I was concatenating it into a query. JavaScript was doing type coercion to take my array of a single value, which was a string, coerced it into a string, which made it work. So, good catch. You get 2 cookies. But now we're at a point where the parameterized query works. And proving Josh wrong that he didn't delete my team's database because that query just worked. Yeah, if I had multiple values that I was looking for, let's say, for example, where I had and teams.city equals 2. And then I could do here Vancouver as an example. The other thing that I could have done here, if I wanted to be really sneaky, to get around that, is I could have just put team here without the bracket 0 up here, and then that would have worked, because then it would have been an array of a single value. But I like this better. But to my previous point, and teams.city equals $2, then I can go here, and just for the moment I'm going to add Vancouver. And it still works. It does what I want. It's just building a more complex query at this point, but I can parameterize multiple values. Anything that ever comes from the user, in fact, anything that ever comes from an untrusted source, meaning from an API, from the file system, from user input, anytime I'm pulling data from outside my script in any way, shape, or form, if I'm going to take that data and plug it into the query, I want to make sure that that is a parameterized query in every single case. Because if I don't, I am opening myself up for SQL injection. Yeah.
So how does the parameterized query actually protect us?
Oh,
Someone just enters the same.
awesome question. Thank you. So how does the parameterized query actually protect us? So here's what's actually happening. The PG library, when it goes to take the first value out of the array of values and plug it into $1, it takes that string and it looks for anything syntactically in that string that would be considered like SQL syntax. Excuse me. So it's looking for quotations, semicolons, dashes, anything like that that might be considered SQL syntax, and it's putting a backslash in front of it. So that is what we would call a delimiter or escape. And that means it's no longer being interpreted as syntax, it's just being interpreted as a string. As text. And so by doing that, it nullifies the effect that any of that syntax might have on my query. So the really cool thing that you can see, so true story, in fact, James could probably speak to this story even better than I could. A few years ago, we had a student do a midterm project that found its way somehow to the front page of Reddit. And the app was, at that point, it was an interactive story builder, so that you would log in, you would provide part of a story, someone else would log in, they would continue the story in their own way, and each person would build a chapter of the story back to back to back. So the interesting part of doing that was, because it found its way to Reddit, it found its way to the open internet, and it was hosted on Heroku, so it kind of got, how do I put it, hammered. And there was a lot of people trying a lot of things with SQL injection, and so you could look at the database and see this whole stack of usernames that were like some combination of quote, semicolon, drop table users, dash dash, like all different variations of that to try and maliciously do something to the database. And that was when James and his midterm team learned about parameterizing queries. Isn't that right, James? Maybe. It's a real thing. And the worst part about SQL injection is that people tend to have what I will call a very rosy outlook on, oh, nobody would ever do that to my app. No, there's not bad people out there. There's bots whose sole job is to hit domains and find websites and try and SQL inject them. It's not even a human doing it. It's a bot that as soon as a new subdomain pops up on Heroku, very first thing it does is goes and tries to find vulnerabilities on it. As soon as you register a new domain and your app launches on it, it goes and tries to find vulnerabilities on it. That's the bot's job. So it's not even about someone maliciously going, oh, I'm going to make this bootcamp student's life miserable. No, it's just a bot. But someone did make the bot, and that person's like, I'm going to make the internet's life miserable. But that's a whole different. That's a whole different conversation. The fact is, we as web developers have an obligation to follow best practice in terms of securing our applications, because users ideally are going to trust us with their data, and especially in these modern times in which we live, where people are finally starting to become aware that when they type things in on the internet, it actually has consequences. So that means that we need to be more and more vigilant about being able to protect our users' data. So with that little bit of a sermon done, go take a break, and when you come back, we'll do a few more interesting things. Okay, so here's how we're gonna take this app a little bit further. Right now, I'm doing node index.js and some team name. I want to change that. So I want to be able to do node index.js, and I want to be able to list basically, a resource, which is a table that I want to look for, and then some search query. So theoretically, I should be able to type node index.js, say team and Vancouver. I should be able to type node index.js, player, Crosby, and that should go and search the appropriate place and do what I want it to do. Now, obviously, there's a couple of quirks to this, because in this case, I'm supplying a city, and I also want to be able to do node index.js team flames, and just type it in that way and have it work. So that changes my query that I now have to write. It changes my logic of how I approach this. And here, well, we know that the names are in there like this. So I have to think about how I do that search in a way that allows me to look for partial strings. Because theoretically, I could just say A, and I want every player who has an A in their name. So that gives me a couple of quirks to how I'm going to code this. So what I'm going to do is I'm actually going to copy index to something called app.js, because this is more of an application that we're now building. And that way you have the original version to look at when I send the code out. And we're going to change how this works. So what we're going to do is we're going to say that the command and the data are going to get destructured out from process.argv.slice2, because that's going to return an array, as we found earlier. And so this, I'm going to take that array and I'm going to create variables called command and data. So command is whatever the, comes right after the file name, and data is going to be the next thing in the list. My config is going to stay the same. My client's going to stay the same. My connect is going to stay the same. But now I need a function to find the teams. And we'll pass the data to it. And I need a function to find a player. And we'll pass the data to it. So, for now, I'm going to get rid of that one. So if I'm finding the teams, actually let's be smart and let's pass both things, because this could be coming from another module, so we may not have scope. Theoretically, these functions might live in another module, and so I want to make sure that it's going to have scope. So client, and let's follow this pattern because it is a good pattern. So if I'm trying to find the teams where, and then if I'm just given a single string, and it could be one of a number of fields, how do I handle that in a SQL query? Because I'm looking for teams here, I'm given a string that could be one of a different, one of a couple fields. How do I handle that in my query? Is there a way I can do it in one query? Or, yes, 100%. So select star from teams where city is equal to $1 or name is equal to $1. So I'm going to make a parameterized query from the very beginning. And I'm going to make my values be an array that is just that data. And I don't need to put two copies of it in there because I can reference that parameter twice. And then client.query, query values. And then res.rows.forEach, which should be a team. And actually, we know we're looking for just one team, so let's add a limit 1 on there. And what we should be able to have is team.city, team.name. Found. That should work. And then we would have client.end. So that would be how we would find the teams, theoretically. And then if we want to find the player, so we know we're going to be looking up by name. We're not looking up a position. We're not looking up a goal. So we know we are looking up from the name field. But how do I do a partial match in a select query? Like, yes. Aaron was quick with that, just bam. Where name, like. And then what's my wildcard character? Percentage, yes. $1, percentage. And we're not going to put a limit on this one because theoretically we might want more than one result. And values equals data. And then client.query, query values, air, res. It's almost like this is a pattern. Res.rows for each player. Console.log. And then let's have player.name plays player.position and has scored player.goals goals. Client.end. So there's some logic. Now we just need to add the actual part of our application logic that says if command equals team, then find team, client, data, else find player, client data. Everybody comfortable with that? Yeah. Client is coming from line 12. That's me creating the actual Postgres client to talk to my server.
Okay. And the data is coming from the
Line 3.
Of course. Okay, I see the data there.
Yep. Always best to double check.
Yeah, I've never seen a variable called with square brackets or anything.
So with the square brackets, that's it's still me doing destructuring. It's the same thing as if we saw in the documentation they did.
Right, the dot instead of putting the curly braces before.
Where were we? They did this. They did the curly braces around it, so that way they could pull out Of the object that was returned from requiring NPG, they pulled out the keys of pool and client and saved them in their own variables. And we were able to do that because this is the object syntax, curly braces. If what I have is being returned as an array, I can do the same thing. I just do it with square bracket syntax because that's the data type that's being passed back to me. So I have the ability to do it with both objects and arrays, which is super cool, yes.
Does it matter if they're in the wrong order? Like
Nope.
It's matching to the name, not to the index
Ooh,
in the object.
ooh, in the object it doesn't matter. In the array it does matter. Yeah, because in the array the order definitely does matter.
It's sort of the equivalent of having the 0.
It is the equivalent of having
Command 0, data is going to be 1 in the array that comes in the process arg thing.
exactly. So yeah, in what's coming back for Victoria's benefit, for what's coming back from process.argv, this is the equivalent to me taking the index 0, setting it to command, and index 1, setting it to data. Yes. Yeah, this kind of destructuring is super useful because it lowers the amount of syntax you have to write later in your code and allows you to scope a variable for it as well. So it is super useful. You just do have to watch out, knowing. It's why I advocate so much on knowing what your return values are. Which, if I had thought about it earlier, I wouldn't have run into the problem of this being an array. But knowing that this is going to come back as an array lets me know how I can access this data in a better way. The other thing that's really cool is we can always just play with it. We can make ourselves a list, and then we can say A and B equals list. And if I look at A, I get apple. And if I look at B, I get banana. So, if you see syntax like that you've never run into before, I highly advocate jump into the REPL and play with it. Because this way you can actually question your assumptions and you can validate what's coming back. And you'll notice, for example, that cherry hasn't gotten assigned to anything in this particular case. My list also hasn't been changed at all. The original list is still there. But what I've done is I've just destructured out 2 local variables for myself to get access to bits of that data. Yeah. So that's a cool way to, when you see new syntax, like first couple times I saw the spread operator when it first came out for ES6. I literally had the WTF, like what's this for, and had to figure out, like with the REPL, how to use it. And once I played with it for a bit, I'm like, oh, okay, and the light bulb came on. But yeah, it took a few minutes. So if I do team, and let's say Vancouver, because that was one of my examples that I wanted to be able to do. Womp womp. I get a syntax error because apparently I forgot how to code. On line 26, I am missing a closing parenthesis after that for my for each. And let's make sure I didn't do the same thing here. I did. Oh, no, I didn't. I'm good there. And the only reason it worked out is actually because I made a block when I didn't need to. So let's try that again. Find team is not defined. I really do know how to code, I promise. Find teams, but find player singular. Okay.
Yay.
Found Vancouver Canucks. Yoo-hoo! Now let's test it with a different example here. Let's do Flames. Found the Calgary Flames. If we really want to test it further, we can test, I don't know, Washington. Found the Washington Capitals. So, cool. That OR statement works for us. We're allowed to now pass either a city name or a team name and get what we were looking for. So what happens if I do that? Womp womp. It didn't. It did nothing.
Oh,
Right. We only did the partial for the players. Yeah, the fuzzy matching, which sadly is actually the name for what that's called. That's called fuzzy matching. Um, oh, it's so fuzzy. So let's test players real quick. So player and uh,
Nick, yeah.
just Nick. Okay.
Let's see. Wasn't that word Nick?
Bind message supplies one parameter, but prepared statement requires 0. So it broke. Cool. We're name like. Do. Huh. It's telling me that it doesn't like that.
Oh, you have to escape. You don't have to escape out.
No, because then if I escape out the percentage, then it would think that there was literal percentage name.
The variable name, but that
That doesn't make sense either, because then it would be looking for that string. I will tell you ahead of time, this is what we call a gotcha. You can. Now this doesn't break my rule about interpolating data, because it's still a parameterized query. And this should solve my problem. Yes?
Does that mean that you could write play, Nick, and it would still work? Is the data coming in with those things?
So the question there is, can I write play, Nick, and it still work? Yes, but not for the reason that you think. The reason I can actually write node space app.js rutabaga, Nick, and it will still work because, yeah, all I'm checking is whether the command was team, and anything else goes to the find players.
Well, let's say if it was an else if statement, would it work for that little line?
So if unless I was doing a partial match to test and see that the command started with play, it would be looking exactly for player. And so right now, if I put in team, it goes to the find teams. Anything else goes to find player. I actually don't need an else if. I just need another if. Else if doesn't exist. End of rant. So if command equals player, then it will do that. You know, if I really wanted to start getting robust with this and have it handle things better, I would write a switch case here. And that switch case would then catch team and player and have a default, kind of like a failover, that would say, like, I don't recognize that command, or show a proper usage line for how this script should be run. That would be the more robust way to do this. But with only 2 commands, it works for just doing like these 2.
Yeah, and that's just so that the user, if they punch in something and nothing's returned, they're not like, this app's broken, and they don't realize that they're not doing it properly.
Exactly. You always have to consider the product that you are making and the user that you are, using it for. One of the things, for example, that we're not doing with this that we should be doing, and is an incredibly valid thing to do with a database-driven application, is we had that one case where we were looking for Washington with a partial string, and we didn't find any matches because we weren't doing a partial search. So we got no results, which meant we got no output. So we might want to come up here, and as part of our pattern that we are doing, if res.rows.length, we will do this, else console.log no results found. That way we actually have a nice elegant output if what we were looking for didn't exist. And then we'd want to take that same idea and do it there. And so since I'm being all so there we go. Now I'm taking this, and this is kind of that idea. Is it basically the mentality is like red, green, and refactor. The red is it doesn't work. The green is it's working. I've solved the basic problem, and then I want to take the next step and refactor. Josh asks, there's a light bulb that comes on with this stuff. Yes, sometimes it's just a candle though. So yeah, now if I start adding more commands, now it's easier for me to add them in. It's less logic I have to write now to add them in. And I have the ability to just say node app.js, and I get, I get kind of a proper output there of what I would expect to have happen. And if I do node app.js fluffy bunny, I get my usage thing giving it there for me as well. So since we've got 7 whole minutes, let's actually add a command for ourselves so that we can take this further, write more queries, connect more data. Let's have case roster, and then we will do what we did with listing the players for a particular team. So function roster takes in client and data. Our query, select star from players, left join teams on teams.id equals players.teamid, where team.name equals $1 or team.city equals $1. So we'll use the same kind of fuzzy matching that we used for finding our team. In this case, it's not really fuzzy. It's just we're able to put in either the name or the city of the team. And so for this, we just need the data. We don't need to wrap it in the percentage signs. Client.query, query, values, error, res, if error, if res.rows.length, res.rows.forEach. Well, let's start off. Well, we don't actually have the team name. That's fine. For each player, we will console.log player.name plays player.position and has scored player.goals goals. Else console.log no results found client.end. It's almost like I've typed something like that before. So now node app.js roster Canucks. And missing from clause entry for table team. Probably because where teams.name or teams.city equals that, my fault. Huh. That's weird. Why did that happen? It does know whether it's a city or a name. That's not why that happened. Canucks, I'm getting all the different positions. I'm getting all the different goals, minimal though they may be, but it's the Canucks. What can you expect? Yep. And I will tell you, perhaps helpfully, perhaps not, that 100% of the problem is on line 56.
Yeah, look at the asterisk.
That's kind of the problem, but not really the problem.
Oh, because left join teams should join the other way around.
Why should I join them other than that? Because I want the data that's inclusive in both tables. Anyone want to jump on why this is causing a problem? This is another gotcha. Nope, because the players.teamid, each player has a team ID field on it, and that is connected to, or it's a foreign key pointing to the ID field on the team's table. That's how we join. And that worked before. Like this exact same query worked before. Almost the exact same query. So Shmoo, you were right that the asterisk is part of the issue, but not directly. So I'm going to solve the problem, because since we're only showing 3 things, I'm going to specify those 3 fields in my output. And I'll even change this, and I'll look up the same players, but I'll look it up by Vancouver. And it works. And if I look it up by Canucks, it works. Yeah. You get the rest of my stack of cookies. It is because teams has a name column and players has a name column, and because I left join teams, basically name got overwritten. So this is a quirk of programmatically dealing with this data. Remember how I said that even though I was joining data from 2 tables, before what I had done is I had specified which fields I wanted back from players, and it gave me those fields in my object. So one of the quirks of dealing with this is when you are doing joins and using the PG module, you want to be explicit about what fields you're selecting out, because otherwise it will get confused about which one to name something if they share a name.
So because they join together in a table,
Mm-hmm.
you're looping through that table, you've declared for player, and then it's saying, okay, every one of these things is a player. It doesn't matter that it came from the players table or from the whatever
Teams table.
that was there before. It's like this is our new table that we're working with.
Mm-hmm.
This mad like volatile health table.
Yes.
And yeah, okay. So play, and you're like, and it's saying, okay, with player name, this is the first name, it's Canuck.
Yes. Because I was explicit with saying I want that column of players.name, then there was no ambiguity now between which one it was. And I like the way that you described that of the table basically existing in this, purgatory null space, because we always have to remember that at the end of the day, the whole goal of a select query is to create a temporary table of results for us. And when we join, we're just building a bigger overall pool of data from which we will then filter down. Did you guys go over yesterday the order in which the clauses of a select query run?
I mean, I think some of us figured it out through trial and error when working on the zoo. I know I've had a couple things get fixed by reordering.
So if we just take a look at this query right here, select star from teams where city equals blah or name equals blah, limit 1. What's actually going to happen is the from is going to happen first. So SQL is going to go to that table in where it's stored, load up all the data from teams. It is then going to apply the where filters, and it's going to return all of the ones where city or name equals something, what I'm looking for. And whether there are one or more queries at that point, it is then going to limit the number of results to one row, and then apply, it will then limit the columns based on whatever I select in the fields. So the initial select whatever is actually like the list of fields that I want is the last thing to be applied. It's the last filter. So the table goes first, the where queries filters go second. That's when we start to see things like group by and order by and limit. They all kick in after that point. And then the last thing is to limit the number of columns based on what fields are being selected. So understanding that that's the order that it goes in starts to make a lot more sense when we look at something that is like this join query. So SQL is going to go and get all of players. Then it's going to left join all of teams to make one big mega super Voltron table. From that, it's going to filter the ones out where the teams.name or the teams.city is the parameter we've supplied. From there, it's then going to filter out the columns to be the players.name, players.position, and players.goals. So that's the order in which this will operate. Because the whole goal of the select is creating that result set for you in table format. Even if I do select count, we're getting a table that has one column and one row called count, and then the number. It's still doing the same thing. It's still doing that filter and that aggregation is the very last piece, and so I end up with a table of one row and one column. So understanding that order of operations becomes super helpful when you are trying to debug a query, because then if you are sure that, worst case scenario, you convert it to select star so that you know that you're going to get everything, and you then debug your wheres, you debug your group bys, your order bys, you debug your limits, then you debug what columns you actually want to get back. Typically the columns is going to be the last thing. Star is just kind of like, fire hose of data, and then you limit it down because then that becomes more optimized. Cool. So yeah, now we've got an app that we've written here. Theoretically, we could add in commands that could insert or update. We could change players' positions or something like that. It would just be us adding a new command, writing a new function that would have a new query and new values, and then following this pattern. And if we really wanted to improve this app the next level, we would we would write ourselves a function that would do all of this, allow us to pass the query in, the values in, and a callback for handling the results. That would be our next step. So up here at the very top, I would probably do a do query, query values and callback, and then I would grab all of this, and I would put it there. I need one more thing. I need the client. And then here, I would have do query, client, query, values, and in this case, that would be my callback. I would change that to be CB because everything else is the same. Do query, client, query, values, and everything else is the same. And guess what I'm going to do here? Client, query, values, and I have now dried out my code considerably. So now I have one workhorse function that actually does all my querying, and I have, because I followed the same pattern for every single thing I did, I can now abstract that out. That one function gets called by all of my different command functions. My command functions build the right query, set the right values up, and then pass that here so that it can be queried that way. And then the callback is what's going to get passed to the for each here when I loop over the rows to actually display the output. Make sense? Cool. Let's see if it still works. Yay, that works. And team, let's say Dallas. Found the Dallas Stars. Player, Sedin. There we go. Clearly, whichever season I pulled this from, that was a crappy year for those guys. So, PG is the underpinning. Any other library that we ever look at, and this afternoon we're going to look at connects. But any library that you're going to use is going to use PG under the hood. So this is showing you what's going on. And it's worth it to understand how to do this manually yourself, because this will always work, 100%. Because you know how to write raw SQL, and because you know how to deal with JavaScript callbacks, like I said, at that point it stops being hard. So, any questions about how I got to this point? Crickets and tumbleweeds. All right. Thanks, folks. I'll send this code out.